Welcome to your first video on linear functions. In this video, we're going to be going over definitions that are crucial to understanding linear functions, as well as how to graph a linear function. So let's start off with this table here. I have time on the top, and I have speed on the bottom. So basically, we have time changing, and as a result, we're having a speed that's changing. So the first question we must always ask is, which of these variables is going to be the independent variable and which is going to be the dependent variable? Well, what does that mean, dependent and independent variable? Well, my independent variable kind of sounds what it is. It's independent, meaning it is not affected by the other variable. But my independent variable tends to influence my dependent variable. Or it is not influenced by other variables. Some other ways of looking at the independent variable is it's going to be my input, okay? And my independent variable is always going to be on my x-axis. Another thing with our independent variable in science, this is called our manipulated variable. So that would mean then that my dependent variable is the one that is influenced by the independent variable. So this is influenced by the independent variable. So in other words, you might think of this one in science, this would be our responding variable. It is going to be the y value on our graph. It is also known as our output. So now we're going to graph my table up here. I wrote it down here as well. So some things before we graph we really must understand is my independent variable is on the x-axis and my dependent variable must be on the y-axis. So if I look at this, is time going to be my independent or my dependent? Well, if we think of science, time is always going to be your manipulated variable. So in this case, time is my manipulated, which we said was our independent. So we're always going to have to put time is going to be on my x-axis. And then we're going to know that my dependent variable is going to be my speed. This is going to be on my y-axis. Now, one thing we have to always do is we must always label our x and y axis. So let's go back up here. I'm going to label my x-axis as time, and my y-axis, I'm going to label it as speed. So now that those are labeled, let's see, we're done this, done that, and labeled. Now we want to graph it and figure out more. So let's graph and plot our points here. We want to cover most of the graph. So I'm going from all the way to 16 and 4. So how many points do we have here? I'm just going to put a title of this. So this is going to be time versus speed. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, keep on going up, 12, 13, 14. So we have 14 altogether. So we're going here, we're going up by 4s every time, so we go to 16. So I'm going to say each one of these, in this case here, I'm only going to use 8 of them so I can fit this all in this page. So I'm going to say each one counts as 2. So we're going to go 2, 4, 6, 8, 10, 12, and here I'm going to go 14 and 16. That way I can fit it on the page. Now, over here my x's, well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 again. So since I have 14, I'm going to say every 3 of these is 1. So I fill out most of my graph here. So I have 1, 2, 3, that's 1. 1, 2, 3, that's 2. 1, 2, 3, that's 3. 1, 2, 3, that's 4. So now let's plot my graph. So at 0, we have 0. Then at 1, we ended up with 4. So I'm going to go 1 and then all the way up to 4 and put in my point there. Then at 2, we had a total of 8. So I'm going to keep on going like this and put in my 8. Then at 3, we go all the way up to 12. So I keep on going all the way up till I hit 12. And then at 4, I'm going to go all the way up to 16. So I got to move my thing up here a bit. We're going all the way up and we hit 16. Now, the question here is, the graph title tells you about the graph. We have a graph title. Now all the points are plotted on the graph. Yes, we have that. Now the next part we have to look at is does it make sense to connect the graph? If it does, that means it's continuous. If it doesn't, that means it is discrete. Now these are very key terms. So let's look at this here. Can I have, for time, like 0.5 of a second or 1,000th of a second? Yes, I can. So time's going to be continuous. Well, we've all heard that time's continuous. Now let's look at our speed. Can I have a fraction of a speed, like 0.03, maybe, I don't know if this is meters per second or something like that? Yes, I can. So in this case here, I'm going to say, yes, I can connect the dots. It makes sense to connect these dots. So I'm going to connect my dots like that and draw a straight line connecting my dots. So let's go back down here. Some definitions. Continuous means we could have any value in the graph, or meaning both our x and y could equal to any possible value, being rational or irrational numbers. So we could have fractions or part of something. So it means we could have any rational or irrational number. So this means we can have any decimal or fraction possible as an answer. And if we think about that, time and speed, we could have any decimal or fraction in both my dependent and independent variables. Now let's think of discrete. Discrete means we have very specific values. So if we're looking at the amount of humans, that can't be continuous because we can't have half or partial of a human. So discrete are very, very specific input values or quantized input values. So that means you can't have fractions. This here, continuous or straight line, connect the dots. And this one is can't connect dots. So let's go over a couple more examples. And we're going to be constantly going back to this table over here, or to our checklist for graphing. So I really want you guys to copy down this checklist and make sure you're doing this so you know if you're graphing right. Now, in this question here, we have a garage sale. Sally decides to document the number of people in the garage at a particular time following this information that she found out. So before we do this, number one, first thing we must want to do is we want to figure out what is my independent variable and what is my dependent variable, and then put them on the x and y axis. And then we're going to have to label. So right here, my independent variable is going to have to be my time. It's normally almost always time, so this is going to be my x. My y is going to be over here. It must be the amount of people. Now I look at this, we go from 0.5 hours, and we always have half hour more or less increments. So altogether, I am looking at 11 different things there, because we have 11, so we need 11 along the bottom. Remember, this goes to 14. So on the bottom here, we're going to have time at sale. So time at sale in hours. So I'm going to write at the bottom, time and sale at hours. So that's my x value. Now my y value is number of people at that time. So I have to put on my y, my vertical, number of people at that time. So now we found out what is my independent, dependent. We labeled my independent and dependent. Now we need a title for the graph, and that's going to be number of people at certain times. Number of people at sale at certain times. Alright, so now we have my titles done. Next, we're going to start graphing this. So I said we need 11 on the bottom. We're going to be counting by half an hour every time. So if I'm going to look here, this is going to be 1, 2, 3, 4, 5, 6. So we have most of the graph paper being used. We don't want to make it too small. Then we look here, the max is 9. So I'm going to count these right here, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm still only going to go up to here because there's 14 and it's going to be hard to use. So that's 9. And we have, this is 2, 4, 6, 8. Okay? So now let's start graphing it. So let's say at open is at 0, we have 2 people. So at opening, we're going to have 2. I'm going to change my color for these. I'm going to put that for opening. Next is at the half an hour mark, there was 3 people. So at half an hour, I'm going to have to go up and find 3. Okay? After this, at the 1.5 hour, there was 4 people. So at 1.5 hours, which is right here, I'm going to go all the way up and find 4. Then we have at 2.5 hours, there is 3 people. So at 2.5 hours, we have 3 again. Then we're going to go to the 3-hour mark. There is 9 people. So after 3 hours, we're going to go all the way up to 9. Then at the 4-hour mark, there is 7 people. So at 4 hours, we are going to have 7. And the 4.5 hour mark, 2, and then the 5-hour mark, 4. So the 4.5 hour mark, we have 2, and then the 5-hour mark, we have 4, and then the 5.5 hour mark, we have 1. So that's what my graph is going to look like. Okay, now, should I connect these lines? Well, if I connect these lines, it doesn't really matter if it goes up or down or anything like that. So I'm just going to change my style of pen here. So I can go like this, kind of is going to go like this, which means we can't connect sometimes when the lines go like that, but with this one makes sense. Can I have half a person or a quarter of a person or a 20th of a person? That's impossible. So it doesn't make sense to connect these lines. So we're actually not going to connect these lines, and this is going to be something called a discrete graph, because we can only have certain quantities. We can have discrete quantities. So distinct quantities of people. We can't have fractions of the people. That's why this is going to be a discrete graph, and we do not connect the lines. Also, we could tell this does not make a straight line, so I could also say this is not actually a linear graph. So in our last example, we are comparing toothpicks to the amount of triangles that could be made. So T representing the amount of triangles and P representing the amount of toothpicks. Well, I look at that, the amount of triangles determines the amount of toothpicks needed. Because if I have one toothpick, it doesn't do anything for the triangle. So that way, my input, or my independent variable, is going to be my triangles, and my output is going to be, or my dependent variable, is going to be the toothpicks. Now let's look at this here. I have, for every time I go up by 1, I'm going up by 2 here. So next, I go up by 1. Here, I'm going up by 2. We just add 2 toothpicks, and I can make another triangle, and that's going to give me 7. Then we're going to have 9. Then we're going to have 11, 13, and then 15. If you want, you could try this and make triangles of toothpicks and see the minimum amount of toothpicks you'll need. So now we want to, now that we complete it, we're going to graph it. So how do we graph it? We're going to go again back to this table here, or our checklist, to graph. So we know what is our independent and dependent. That's done. Now we have to figure and label our x and y's. Okay, so let's label them. Then we need a title for the graph, and then we have to see if it's continuous or discrete. So let's go back down. So we know we are going to put my toothpicks, or is going to be my y value. So this is number of toothpicks. Okay, and my x is number of triangles. The title of the graph is going to be triangles to toothpicks. Alright, so let's look at this here. My triangles will only go up to 7, and we have 14 here. So I'm going to count each of these by 2. So this is going to be 1, this is going to be 2, 3, 4, 5, 6, 7. And we're going up to a total of 15. And we only have 14 here, so I might not even get the 7th on here. So I'm just going to count these all by 1. So we're just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now we're not going to make those breaks to shorten these because we're trying to figure out the relationship of the linear equation. So we're just going to keep these continuous graphs. And now let's start plotting. So my first value is 1 and 3. So we start at 1 and we're going to go to 3. My second one was 2 and 5. Then we have 3 and 7. Then we're going to have 4 and 9, 5 and 11, 6 and 13. So if I look at this, we would end up having a nice straight line if we were to draw this. We could connect the dots into a nice straight line. But now, should we connect these dots into a nice straight line? Can I have part of a triangle or part of a toothpick? No, we're either using full toothpicks or full triangles. So we have distinct amounts of toothpicks and distinct amounts of triangles. We're not going for partial here. So therefore, this graph is actually linear because it makes a nice perfectly straight line without a bend. And it is also discrete because we cannot connect the dots for this one. So that's what we've learned so far, and a review of how to graph linear and discrete graphs, and what are certain things as dependent and independent variables.